Okay, Josh is selling beets. He's got 200 pounds of beet right now. Reckons he can sell for $2 a pound. And if he increases the price by 10 cents, he expects to sell 4 pounds less of the beets. So it makes sense, right? You increase your price, you're going to have a few less customers. What's the maximum revenue that Josh can get? So let's start off with this basic idea. The revenue is just how much money we bring in, okay? So I'll just start with an equation, R for revenue. And before we do any sort of manipulating, um, it's $2 per pound at the starting price, and we're selling 200 pounds at that price. So right now our revenue is $400, okay? But Josh said, hey, what if I increase the price by 10 cents? So if I make it $2.10, I lose 4 pounds less. What happened to our revenue? $2.10 times 196. Revenue went up by $11.60, right? So we want a function, that way we can maximize it, because it's probably going to be a quadratic since we keep doing that in this unit. So here's the function you want to do. Look, we increased it by 10 cents, right? And then that made us, we lost 4 customers. We lost 4, oh, well, not customers, maybe. We lost 4 pounds of beets in sales. So that's what I just did over here, just expanded a little bit. Took the original $2 and I added 10 cents to it. Well, that caused our original 200-pound beets to decrease by 4 pounds. If we put an X here, the X represents the number of times we're going to increase or decrease that price by 10 cents. Because X equals -1 would mean we decrease the price by 10 cents, because that's an option too. So X stands for the number of times we increase the price by 10 cents. Okay? So make sure we got that clearly defined in our heads before we go on. X says how many times are we going to do it? We're going to increase it by 10 cents 5 times. So we're going to set it to $2.50. That means you're plugging in X equals 5 into this revenue function. Okay, so now this is a function of X. And now this is something we can maximize because it's going to be quadratic. If you multiply these two parentheses together, 2 times 200 is 400. 2 times -4x is -8x. 2, and then we're done with that one. So 0.1x times 200 is 20x. And 0.1x times -4 is -0.4x squared. Okay, so -8x plus 20x makes 12x. I'll just put this in descending powers. Rearrange this to put the first term out here. Then we got 12x. Then plus 400. Okay, and this is quadratic. The highest power is x squared, and there's no other funny business going on. So we can maximize a quadratic by using this formula, -b divided by 2a. That will tell you the x value that maximizes your revenue. So it's -12 divided by 2 times -0.4. And let's see what that is. It's going to be a positive because negative times a negative. So I got 15. I got positive 15. Now that's not the maximum revenue. Remember, X is what we just found. We found out the maximum revenue occurs when X equals 15. In other words, we increase the price by 10 cents 15 times. Okay. So if you want to know what the maximum revenue is, you need to plug this back into the equation, and that will tell you what your maximum revenue is. So the maximum revenue, we found out it occurs when X equals 15. So if you plug that in here, let's see, 0.1 times 15 plus 2, so it's at $3.50 is what we're charging right now. And then it's 4 times 15, 60, so 200 minus 60 is 140. So $3.50 is the best price to set it according to our mathematics here to maximize the revenue. 140 beets are sold at that price. So the maximum revenue is $490.